time not that long ago, in fact, as recent as 6 years, when hybrid DNS required setting up a DNS solution in the cloud. This was a quintessential example of an AWS customer performing undifferentiated heavy lifting themselves, until the savior Route 53 resolver came around. Welcome to Conf42 Platform Engineering Conference, and thank you for attending this session. I'm Atif Siddiqui, Senior Principal Software Engineer at Silicon Valley Bank, Division of First Citizens Bank. The agenda will cover the original problem statement when there wasn't an adequate offering from AWS. I will introduce Route 53 Resolver service and explain the key concepts. It will be followed by a solution for hybrid DNS for multi-account setup. In addition, I'll elaborate on the key design considerations as well as native security tools that are available to us. I'll wrap it up by talking about a new capability released this year called Route 53 Profiles. Until the time Route 53 Resolver was announced, customers had two paths: choose a marketplace product or come up with a custom solution to set up hybrid DNS. The latter, while likely to be more economical, relied on setting up DNS servers on EC2s. The responsibility of setting up resiliency also fell on the customer. All these challenges evaporated when Route 53 Resolver was announced 6 years ago. Before I delve into this topic, let me do a quick sidebar. When a VPC is provisioned, the .2 IP is reserved to resolve DNS queries originating from the VPC. For example, if a VPC has a CIDR of 10.0.0.0/23, the IP 10.0.0.2 is what provides the DNS resolution. This is why historically it used to be called a .2 or a +2 resolver. This has all along been a default feature of VPC. It should be noted that if a VPC has multiple CIDRs, it is a primary CIDR where the +2 IP is what's used for DNS resolution. Circling back to Route 53 Resolver, it was announced in November 2018. This offering was specifically targeted to simplify DNS for the hybrid cloud use case. Any enterprise that ventures into cloud will almost always have a hybrid network that is having both on-prem and cloud presence. This means there's a requirement for on-prem network to resolve workloads in AWS. Similarly, resources in AWS may have a requirement to resolve private DNS records on-prem. This requirement is solved by the introduction of resolver endpoints. There are two types of endpoints, inbound and outbound, and this terminology is from AWS standpoint. Inbound resolver endpoint is for queries coming into AWS from on-prem network. It is used to resolve VPC resources from on-prem. It is important to note that on-prem DNS must issue recursive instead of iterative queries to the Route 53 resolver's inbound endpoints. On the other hand, outbound resolver endpoint is for queries going from AWS to on-prem network. It is used to resolve private DNS records on-prem. These resolver endpoints manifest as elastic network interfaces or ENIs. Therefore, the best practice is to provision these endpoints in every AZ that the VPC spans to. While I expect the audience will use infrastructure as code, the console screenshot is to illustrate some of the key points. As Route 53 Resolver is a regional service and a VPC resource, it should land in a shared service account such as core network. As this is an ENI, it requires a security group. For the inbound resolver endpoint, security inbound roles should open for port 53 for both TCP and UDP protocol. On the flip side, for outbound resolver endpoint, security outbound rules should be open for port 53 for both TCP and UDP protocol. This example shows a VPC spanning two availability zones. The default behavior when provisioning endpoints is for AWS to grab an IP from the subnet of VPC. Alternatively, one can specify IP from the subnet. Needless to say, these ENIs get allocated private IPs. Outbound resolver endpoints are complemented with a forwarding rule. This forwarding rule applies to VPC traffic destined for on-prem. This is why on-prem DNS servers needs to be configured on this rule. In this case, the on-prem DNS server is listed as 10.50.50.50. Circling back to the comment how ENIs are created when resolver endpoints are provisioned, here the diagram shows 4 ENIs. This is a VPC spanning two availability zones, and hence we have a pair of inbound and outbound endpoints respectively. And then this shows how the secured inbound rule should look like for the inbound endpoint. Only traffic on port 53 for both TCP and UDP protocol is allowed. This rule assumes that on-prem network is using a class A CIDR of 10.0.0.0/8. There are two other key points to talk about before we can look at the design. The first one is, once the resolver endpoints have been provisioned in a shared service account, the question arises, how will it be shared across the spoke account? Enter Resource Access Manager or RAM. This is an AWS service that has the goal of sharing resources across accounts within the AWS organization. Route 23 resolver is one of many types supported by RAM. Some of the other examples are system manager parameters, RDS cluster, backup WAS, etc. The second key point is to understand the concept of a VPC association to private hosted zones. In this case, private hosted zones across all spoke accounts will need to be associated with the VPC and shared service account where the endpoints were provisioned. It will allow shared service account to resolve private DNS record across all spoke accounts. This design encapsulates the talk up to this point. In the top, it depicts a shared service account where resolver endpoints have been provisioned in a VPC spanning two AZs. In the first use case, indicated by blue arrows, the request originates on-prem. An on-prem user is looking up a resource in one of the two spoke accounts. On-prem DNS server will forward a request to the resolver's inbound endpoint. Since the private hosted zone of spoke accounts are associated with the VPC network account, resolution of private records such as EC2 is possible. In the second use case, indicated by orange arrows, request is originating in a spoke account. The EC2 resource is looking up an on-prem system. There is a forwarding rule for corporate domain, let's say star.conf42.io, associated with the resolver's outbound rule. In addition, this forwarding rule is shared with spoke VPCs via Resource Access Manager. The outbound endpoints are also configured with the IP of on-prem DNS server. Early in the deck, IP of on-prem DNS server was set up as 10.50.50.50. It is important to call out that while what we have talked so far achieves DNS resolution in the hybrid setup, isolation of VPCs still applies. How packet flows between VPCs still needs a networking construct. That construct is transit gateway. Similarly, networking path between on-prem and edge VPC of a network account will either be a VPN or direct connect. When it comes to DNS setup, there are two security tools that should be a part of your ecosystem. Guard Duty is the first one, a service that I'm a big fan of. It to me represents the pinnacle of how security products should be delivered. Single click of a button to enable it, and it passes through 3 sets of logs, including DNS, to identify threats such as data exfiltration through DNS queries. Over the years, this service has had enhancements and extends its reach into specific services such as S3, EKS, and RDS. Security Tool is a ROC 3 resolver DNS firewall. This is a relatively new service and was announced in early 2021. It provides the capability to regulate outbound DNS traffic originating in the VPCs. It supports both AWS managed domain lists as well as a custom one. Managed list is a good way when looking to introduce a service into your ecosystem. As with any typical firewall, there are 3 action types that can be configured: allow, block, and alert. This action can be applicable to a specific DNS record type or a broader firewall rule that will apply to all DNS record types. The last subtopic I would like to talk about is the announcement from last April. AWS announced a new capability called Route 53 profiles. The value proposition is that a profile allows bundling up private hosted zone associations, forwarding rules, and even DNS firewall rule groups. This profile can then be shared via Resource Access Manager across accounts in AWS organization. While I haven't had a chance to play with this capability, it will certainly make the hybrid design both simpler and cleaner. There is no escaping DNS, and everyone just expects it to work. Therefore, to implement a solution in a resilient manner using AWS managed services is an excellent position to take as a platform engineer.